Hi there. This is a re-recording of part 2 of lecture 8 for EC4408 Industrial Organization. The topic of lecture 8 is research joint ventures, and in part 1 we examined the standard model of research joint ventures as summarized neatly by the Daspremont and Jacquemin model. One very important element of research and development that is missed in the Daspremont and Jacquemin model, and by a large part of the literature on research joint ventures, is uncertainty. Now, we are used to making simplifying assumptions, which are absolutely necessary in order to try to formulate a model that can be used to understand any kind of relevant phenomenon. But to assume away uncertainty in the case of research, in my view, is not a simplifying assumption, is missing what is probably one of the key features of research. If by investing in research and development you know exactly what you're going to get, that is not called research. It's called solving a known problem. So what I'm going to do in this part 2, I am still within the confines of the standard model of research joint ventures. I will introduce uncertainty in the simplest possible terms and see where it takes us. In lectures 9 and 10, we will be looking at a different way of looking at uncertainty in the context of research by using the example and the principles suggested by John von Neumann. Okay, so let's look at the simplest stochastic process we can think of. A firm, by investing a given amount X, effectively buys a lottery ticket. A lottery ticket that will allow that firm to produce a successful product with probability P. Knowing the probability of success is not enough to determine the payoff that firm will get from its investment X. Why not? Because if there is more than one firm in the market, and here we are going to assume a duopoly, so there is another firm in the background, even if one firm succeeds, that doesn't tell the firm what its payoff from investing X is, because it depends obviously on whether the other firm succeeds or not. Because if it does succeed, then the two firms with probability P will move on to compete in the final product market and therefore earn duopoly profits. Whereas if my rival fails and I succeed, I will enjoy the much larger monopoly profits. And in fact, we looked at one such example in tutorial 1 or 2, so this should come as no surprise to you. So we can see here let's highlight here the profits that would accrue to a firm that does independent or non-collaborative research. Obviously, everything is conditional on that firm succeeding, and that happens with probability P, but the actual payoff will be a weighted average of monopoly profits and duopoly profits, and from that we have to subtract the cost of research. So it's our baseline. What happens if the two firms decide to form a research joint venture whereby they instead of conducting research separately, they just invest X between the two of them, sharing the cost and also sharing the lottery ticket. If the lottery ticket that investing X gives you produces a success with probability P, then both firms will use that piece of information and therefore will be competing in a duopoly, hence the duopoly profits here. Okay, so all we got to do now is to compare those two profit levels, and that will give us a very simple rule whether or not a research joint venture should be formed. And as expected, that inequality will depend on three main factors. First of all, the probability of success. Secondly, the degree of competitiveness in the final good market, i.e. how much bigger monopoly profits are compared to duopoly profits, and also, of course, on the cost of research X. Now, the diagram that goes with that inequality is perhaps slightly more intuitive, and it tells us that a research joint venture would be profitable, or rather more profitable than doing independent research in two quite different cases, namely when the probability of success is very small or fairly large. Why is that the case? Well, the intuition should be fairly clear. Suppose that the probability of success is very close to 1. What does that mean? It's good news insofar as if I invest X, I'm pretty sure of being able to develop this product successfully. On the other hand, the same thing applies to the other firm. So the chances are that if we invest separately, we will both end up in a duopoly anyway. And so by forming a research joint venture that shares the cost of R&D, we will be almost certainly saving money, and therefore that's what we should be doing. At the other extreme, suppose that the probability of success is very small. Then it's the same argument in reverse. Then the probability that either firm would be able to develop the product is very small, and therefore you may as well share the cost of that very difficult research. Now, obviously, in this simple model, if a research joint venture is more profitable than independent research, it should be obvious that it's also welfare superior. Why? Because profits will be higher under a research joint venture by assumption, and the market will be a duopoly, which is bad, but not as bad as monopoly. So consumers would be better off if both firms compete as opposed to having a monopolist. Okay. That is if this investment in R&D gives us a bang result. Either we succeed with a given probability p, or we fail with probability 1 minus p. What if, as is almost certainly the case, firms could vary the probability of success? And obviously, the idea is that the more you invest, the more likely it is that your research will end up as a success. Okay. So what I want to do now is to eliminate from the scene what I've just said, namely that increasing the investment in R&D will produce a higher probability of success. And instead, I want you to consider the following scenario. Okay, we have our two firms that, of course, when it comes to selling the stuff, will both behave non-cooperatively, namely they will not act as a monopoly. So if they form a research joint venture, they may end up both competing in the final market, and they decide to jointly own a research lab that produces research prototypes. Okay, and these research prototypes can come in two varieties. Okay, they can either always be turned into a marketable product. I'm going to call these prototypes perfectly reliable, or it can turn out prototypes that are unreliable, namely that can be turned into a marketable product with a probability less than 1. Now, the key idea here is that producing perfectly reliable prototypes and or unreliable one costs the same. So I obviously I am biasing the outcome against producing unreliable prototypes. Why would you want to waste your investment in R&D by telling your research lab to turn out prototypes that sometimes fail to be turned into marketable products, when for exactly the same cost you could have perfectly reliable prototypes that by definition can be produced, can lead to a marketable product. Now we have, if this is an open question, in the sense that, and this is the key tension that you have in any research joint venture. If both firms instruct the research lab to produce perfectly reliable prototypes, you know exactly what is going to happen. Both firms will then turn those prototypes into marketable products, and therefore will end up in a duopoly with certainty, and therefore will earn duopoly profits. On the other hand, if the lab turns out prototypes that are not perfectly reliable, and each firm therefore has to use that probability of success less than 1 to market its product, there is a chance of monopoly profits, insofar as you may be lucky and, in fact, be successful in turning your prototype into a product, whereas your competitor may turn out to be unlucky because the prototypes are not perfectly reliable. And then what? In that case, you will be earning monopoly profits. Okay, so it is an open question whether or not you would always want your jointly owned lab to produce reliable prototypes. So again, we have to check whether the unreliable option is more profitable or not, and a simple rearrangement will tell us something that we may already suspected, namely that whether a research joint venture should yield always duopoly profits or have the possibility of earning monopoly profits will depend on, guess what? The competitiveness of the final product market, i.e. how much larger profits are compared to duopoly profits, and of course on the probability of success. But firms obviously will optimize in the sense that they will not just tell their research lab, okay, go ahead and produce unreliable prototypes. They want the prototypes not to be too unreliable, but they certainly don't want them to be totally reliable. So how do you choose the right degree of reliability? Well, you maximize your expected profit with respect to this crucial probability. So here we are. This is your expected profit, which depends on the probability of success, and you can then instruct the lab to turn out prototypes that succeed with a probability P star, which is the probability that maximizes your expected profit. And again, guess what? The probability of success will depends on the interaction between monopoly and duopoly profits, but that is always going to be a certain result. Namely, we can say for sure that the optimal probability of success will be a less than 1. How do we know that? Fairly simply, we need an index of competitiveness of the market. Okay, so let's look at this. Let's look at this expression here. What we have done here is to write monopoly profits as a certain multiplier of duopoly profits. We know that as long as firms compete, monopoly profits will be greater than twice duopoly profits. If they were exactly, if duopoly profits were to be exactly twice as large, if monopoly profits were to be twice as large as duopoly profits, it means that the two firms collude perfectly and share monopoly profits. Therefore, our parameter alpha is going to be greater than 1, and the greater is alpha, the more competitive is the market, meaning that firms dissipate a lot of monopoly profits by competing. Okay, so with that in mind, we can then write the probability of the optimal probability with which the two firms will instruct the lab to produce a prototype is always going to be less than 1. Meaning that even if you could produce at the same cost perfectly reliable prototypes, you would not want to do that because that would not maximize your profits. Okay, the final part of this topic of research, joint ventures, and uncertainty refers to the short article by Combs that is interesting because it's one of the earliest papers to introduce the idea of research design. What is the simplest form of research design? When we think about research joint ventures, we assume that once this joint venture is formed, firms will not just carry on research as they were doing before, but there will be some redesigning of research strategies now that firms have decided to cooperate. And the idea is that, of course, you will try to different firms will follow a different research path, and that therefore increases the probability of success of the venture as a whole. And what Combs does is to show under what conditions a research joint ventures will be formed, and she gets a result that is almost identical to what we have just described above. So I suggest you have a quick look at this note and see the similarity between the two research joint ventures models. And that is the summary of part 2 of lecture 8.